In this video, we will be deep diving into Sevalla's application hosting. It's a very powerful feature from Sevalla as a platform, as a service provider, which lets you deploy your applications directly from your Git repositories or your Docker images, depending on your requirements. If you have ever struggled with complex deployment pipelines or wanted a straightforward way to get your applications online, then this video is for you. So let's quickly get started with this. Let's start with the fundamentals. Application hosting, basically, it allows you to deploy your applications from your source code, which can be in a platform like GitHub or Bitbucket or GitLab, directly onto Sevalla's infrastructure. So think of it as a kind of bridge between your source code and your infrastructure. Now, infrastructure, traditionally, it's been AWS, GCP, or Azure, etc. Now, Sevalla creates that bridge between the code and the infrastructure with as minimal effort as possible. And when I say application, I'm talking about any software that runs on a server to perform any kind of task. So it can be a web application, an API, or microservice, background workers, or even very complex full stack applications. The key requirement for something to be an application is that there is a server component behind your software. If that requirement is satisfied, then that is called an application. So Sevalla's current infrastructure, it supports applications that follow cloud native principles. And that means that your application should be designed to run in containers and use external databases rather than file-based storages, and should be configurable through environment variables. So those are very basic requirements. And in fact, those are very recommended best practices for any kind of software that our modern workflows demand. Now, using Sevalla, you can create unlimited applications within your company. We talked about company in the last video, and each of them with their own resource needs. You're not restricted by any arbitrary limits on the number of projects that you need. Second, each application can have multiple processes, a web server, a background worker, cron job, scheduled task, whatever you need. And this lets you build very complex modern workflows with different components handling different kinds of responsibilities. You also get concurrent builds. You can build and deploy multiple applications simultaneously without waiting for them. And this is very important if you are working in a team with multiple projects inside that. You can choose from more than 25 data centers worldwide to deploy your applications, depending on the location of your users and the optimal performance for that. For stateful applications, you can attach persistent storage volumes that can retain data even when your application restarts or redeploys. So all these features you get right out of the box when you are using applications inside Sevalla. So when should you choose application hosting? First is if you are hosting any kind of custom applications. For example, you have built a web application in Node.js, Python, PHP, or Ruby, or Go, or any other supported languages that needs any kind of server-side processing. Then you should go for application hosting. Or if you have an API service need, a RESTful API or a GraphQL API or microservices that any other application consumes, which is number 2, APIs. Number 3, if you have needs for background processing, basically applications that need to process queues, send emails, or generate reports, or handle any other asynchronous tasks, then also you can go for application hosting. However, application hosting might not be the best choice if you are building a simple brochure website, basically a static site with static content. Then in that case, Sevalla's static site hosting would be more appropriate for your use case and also more cost effective. Now, one of Sevalla's standard features is the seamless Git integration. You can connect repositories from GitHub or GitLab or Bitbucket. Both public and private repositories are supported. Let's try it out how creating an application looks inside your Sevalla dashboard. First, click on create an app. Now this is the screen that we get whenever we want to create a new application. Here we have two options. we can select a Git repository, either GitHub or GitLab or Bitbucket, or we can also select a Docker image if you want. Inside a Git repository, we also get an option for selecting a private repository, for which we'll have to give account access, install the Kinsta app in our account, or it can be a public repository for which we don't have to do much. We can just paste the URL of the repo and the branch that we want to deploy, and it will be able to deploy that application. So let's select private repository for now, and inside repository we have to give our permission. So click on edit GitHub permissions, clicking on our account. Here we have to select our account, which is this. Now at this screen we can either select whether we want to give access to all repositories or only selected repositories. So let's click on only selected repositories, and here we can search for our intended repo which we want to deploy, which is the next demo repo, and click on install, which will install the Kinsta app in our particular repository. And by going back, let's do a quick refresh, and here we'll be able to see the name of our application here, and we can select that. For branch, the default is the main branch. Since that is the only branch available, it does not show any more options. At this step, we also have an option which we can select, which will deploy every time we push a new change into our main branch, which is our complete CI/CD workflow, which is very convenient if you are working in a team. And this is one of the key advantages of choosing a Git integration as compared to the Docker image based workflow. For the Git integration, you can just push into the main branch and your application will update automatically. You get deployment history, rollback capabilities, and you can see exactly which commit is running in your production. So kind of a commit-based versioning you will get right out of the box. Similarly, we also have an option for Docker image. Now, if you prefer containerized deployments or need more control over your build environment, you can deploy Docker images instead of Git repositories. So Sevalla supports both public and private Docker images from multiple registries. You can either choose Docker Hub for public images, you can choose GitLab container registry for GitLab users, or if you use GitHub, you can also choose GitHub container registry for private images. Now, if you're thinking when should you use a Git integration and when should you choose a Docker based workflow, then couple of thumb rules are: one, if you have complex build requirements that need custom environments; second, if you are using languages or frameworks that are not directly supported by Nixpacks or Buildpacks, which are the two build systems of Sevalla; third, if you want to pre-build images in your own CI/CD pipeline, then also you can go for a Docker based workflow; fourth, you are working with existing containerized applications in your existing workflows and you are transitioning into Sevalla, then in that case, to minimize the friction as much as possible, you can go for Docker based workflows. So again, with Docker images, you will get full control over the build process, the dependencies, and the runtime environment at the same time. The Sevalla will of course handle the deployment, the scaling, and the infrastructure management, of course in the Docker based workflow also. But for the build environment, you have the flexibility to choose either a Git based or a Docker based. Since we are talking about build environments, let's talk a little bit about the three different kinds of build options that you get in Sevalla. Now, when you deploy from a Git repository, Sevalla needs to transform your source code into a running application. That is the end goal of any platform as a service provider. This whole process is called building, and Sevalla offers three different build environments to handle this whole transformation from getting the source code to a live environment over the internet. So think of this as three different strategies for taking your code and creating a container image that can run your application. Each approach has its own strength and is suited for different scenarios. The build process that happens on a dedicated build machine, separate from your runtime environment. It does not happen in the same container, in the same pod where your actual servers are running. It happens in a different containerized environment. So the build performance does not really affect your runtime application. Now coming back to Nixpacks. Now Nixpacks is Sevalla's default build environment, which is an excellent choice for most applications. Originally, Nixpacks was created by Railway. Railway is again a platform as a service provider, and Nixpacks is a completely open source project that automatically detects your application type and it sets up the appropriate runtime environment depending on what kind of application that you're trying to deploy. And what makes Nixpacks special is it supports more than 20 programming languages right out of the box. You don't really have to configure any kind of option for this. It automatically does the dependency injection and any kind of package installation stuff. All of that is already configured. It uses less resources than our traditional Buildpacks or traditional build systems. And it is very highly optimized for performance and security. So as you can see from here, there are a lot of languages that are supported using Nixpacks. You have Node.js, Python, PHP, Ruby, Go, Rust, Java, Elixir, Haskell, Swift, whatever you need. Pretty much all the modern programming languages are supported right out of the box. So the beauty of Nixpacks is its simplicity. In most cases, you just point it at your repository and it just figures out how to build and run your application. It looks at files like package.json if it is a Node.js application, and requirement.txt if it is a Python application, or composer.json if it is a PHP, to understand your dependencies, and then it just installs them as for your language, for your framework. You can also customize a file, which is the nixpacks.toml file. If you need more control, most likely you will not need it. But if you need more control, then you can edit various options provided in the nixpacks.toml file to specify things like additional packages, customize the build commands, or define new build phases if you want. For example, if you need to install some system packages or modify environment variables during the build time or custom scripts, things like that, then you can make changes in the nixpacks.toml file as per your requirements. The next option, the next build option provided by Sevalla is the Buildpacks. Now, Buildpacks are the original cloud native build system, which is maintained by Heroku and also the creator of Buildpacks. And it is pretty much used by all the major platform as a service providers. Though they support less languages than Nixpacks, but they are extremely stable and also very well documented. So if we look at Buildpacks, these are the languages that are supported if you are choosing a Buildpack environment. They're Node.js, Ruby, Python, Java, Scala, PHP, or Go. The advantage of Buildpacks is the maturity of the ecosystem. They've been around for a long time. They've been battle tested in production, and their documentation and the community is pretty extensive. So when to choose Nixpacks versus Buildpacks? If you are migrating from Heroku and you want the consistent behavior of your application, then you can go for Buildpacks. Or if you need the stability of a mature and well-tested system, then also you can go for Buildpacks. Or if you're working with one of the supported languages and don't really need the cutting-edge features provided by Nixpacks, the performance benefits, then also you can go with Buildpacks. The third option, the third build environment that we get is the Docker file. If and when you need the complete control over your build environment, then Docker files are the answer. A Docker file basically contains explicit instructions. So if we take a look at the Docker file provided as an example here for a Node.js application, it provides some instruction at different steps, which helps the system build a container image, and it gives you precise control over every aspect of the environment. So you should use a Docker file if you are using languages that are not supported by Nixpacks or Buildpacks, or you need specific system packages or configurations which are not possible using Nixpacks or Buildpacks, or if you have complex build requirements, or you want to match your local development environment exactly as your production environment. If you have use cases like this, then of course you could go for Docker file based build environment. Now let's go back to our dashboard. Now that we have our fundamentals ready, we'll go with our Git repository for deployment for our first app. And before you do this, make sure you have these things ready. a Sevalla account which is already signed up, a Git repository with an application code. You can just create any Next.js or Node.js application, or you can select a template provided by Sevalla, which you can access from here, and you can select a Next.js template and deploy here. Or going back, you can create a basic Next.js app using the create next command line tool and deploy that. Or if you have an existing application, whether it is a Node.js app, Next.js app, that does not really matter. For this example, I have created a Next.js app using the create next CLI tool, and we'll be deploying that for our first application. One thing to keep in mind is, if you are following along, make sure your application follows cloud native practices, which means that it should read configuration from environmental variables, not hard-coded values. And any persistent data should be stored externally, not in local files, right? With that, we can start. I have already shown the first step, which is connecting with your Git provider and giving permission to your repository. So let's select our repository, and for branch, we'll select the main branch, and we'll click on automatically deploy if we push new changes to our application. For the name, we can give a new name, let's say my next app. For location, as we saw earlier, you can use the GC ping tool that we saw in the previous video to find out which location, which data center region gives the minimum amount of latency for you. For my case, since I'm in India, I was getting the minimum amount of latency using the Mumbai region, Mumbai data center. You should select the region and the data center as per your location or the location of your users. And finally, for the resources, this is basically the pod size that you want to deploy your application in. The size you select, it determines two things. One is the CPU and the second is the RAM. CPU is the processing power, RAM is the primary storage power. Hobby tier is best for development or testing or very light applications. But one thing to note is, if you are using hobby tier, you cannot use custom domains. Then comes our standard tier, which is starting from 0.5 CPU cores to 8 CPU cores. And also you'll get starting from 1 GB RAM to up to 16 GB RAMs. These are the mostly used pod sizes. These are great for modern web applications, any kind of web applications, small to medium APIs, and also pretty much any typical business applications that you have requirements for. We also have two different kinds of pods. One is CPU optimized and another is memory optimized. CPU optimized basically means that you get more amount of CPU cores per GB of RAM. Same way, memory optimized means you get more RAM per CPU core. That is the whole idea. If you have identified your workflows to be more CPU heavy, then you can go for CPU optimized pod sizes. And if you think that your applications are more memory heavy, then you can go for memory optimized pod sizes. So my advice is start with a smaller size and scale up based on your application's actual usage. And since Sevalla has usage based pricing, which means that you'll only pay for what you actually use. So you're pretty safe when it comes to choosing the right instance size. For our application, let's go with a hobby tier, since this is just for testing purpose. For now, let's click on create. We'll not deploy yet. We'll cover a couple of more concepts that you should know. After that, we'll finally deploy our application. For now, let's just create this and save it so that we can deploy with this configuration later on. Our app is finally created. It is not deployed yet, but it is created and we can see it in our dashboard. There are no deployments done yet. That's why we cannot see any deployment listings. The next thing that we should cover is environment variables, which is another important concept. Environment variables are basically key value pairs which provide configuration information to your application from outside your code without hard coding any kind of values. So imagine instead of hard coding your database URLs or API keys or feature flags directly in your source code, you will store them outside your code as environment variables, and you will provide those variables depending on where you are running your application. If you are running in local, You might provide them using a file such as .env and loading with a library such as .env. But if you are running in production, you are deploying somewhere, let's say in Sevalla, then you can provide them using this dashboard. You can provide your environment variables, and Sevalla will inject these environment variables into the operating system, that container, wherever your code is running, so that your code can pick it up from the environment. There are a couple of advantages of using environment variables. The number one is, of course, security. Sensitive information like database URLs or API keys, they do not live in your code. And because of that, when you push your code into version control system like GitHub or GitLab or Bitbucket, there are less chances of your secrets getting leaked. Second is flexibility. The same code can behave differently depending on which environment it is running in. Depending on whether it is development or staging or production, same code will have different behavior, because you are customizing, you are changing the behavior as per the environment variables which live outside the code. And the third is portability, which means that your application can run in different environments without any kind of code changes. Now, in Sevalla, if we talk about Sevalla, there are multiple ways to manage your environment variables. First thing is, while creating your application, you can set your initial environment variables. If not, after deployment, you can come to your application settings that we see in this screen, and clicking on environment variables, you can add your environment variables. You can also specify using these two flags here, whether the variables that you specify here, they are available during runtime or they are available during build time, or both, depending on your requirements. The same way, Sevalla offers another convenient feature where clicking on this import.env, you can just import any of your local .env file, and those values will be loaded directly in the dashboard. Some of the important security considerations that you should keep in mind when dealing with environment variables is never commit your secrets to your version control system, which means that always keep the .env file inside your .gitignore so that it does not get committed into your GitHub, which totally defeats the purpose of keeping it inside the environment variable. Second thing is, another best practice that you should follow is always use descriptive names. You should always choose clear descriptive variable names. Use consistent naming, something like that we see here, all uppercase, and the words divided with a underscore, which we also call is upper snake case. Right? For that, let's come to our deployments. And finally, we can go ahead and deploy our application. Let me click on deploy now button. The branch that you want to deploy is main, and finally we click on deploy application, which starts a new deployment. If you click on this, we can see live what is exactly happening in our deployment phase. From here, we can see that our build environment is Nixpacks and the build path, from where the build environment is picking up the code. This is the root path. If we are dealing with monorepo, this build path will be something different, but since this is not a monorepo, we are taking from our root paths. If we go to the start of the logs, the first phase that we see, that the first thing that happens is it fetches our code from GitHub, which is a very logical step to do. If it wants to deploy our code, then the first thing it will need to do is fetching our code from the GitHub repo that we have specified. Since it already has the permission to get access to the code, it can easily fetch the code or clone the code. After that is done, the first is, number one is fetch, second is build, which means that your code goes to the Google Cloud build, where depending on your build environment, whether Nixpacks, Buildpacks or Docker, it creates a container image. The final output, the final product of our build process is a container image. And this happens on a dedicated build machine with the resource you have provided previously. Third, image storage. The image that was finally built, the Docker image, that is stored in Google artifact registry, which makes it available for deployments and future rollbacks if needed. Fourth, container deployment. The image that was finally built and stored, that is deployed into Sevalla's Kubernetes cluster, which is predefined in your chosen data center that we chose while we were creating our application, and also multiple containers can run the same image for high availability if you need them. And finally, the fifth step is traffic routing. After your build is successful, after the deployment is successful, Cloudflare, the first entry point of any server application, it routes traffic to your application through things like load balancers and the Kubernetes ingress system. The entire process from end to end, this is completely automated, but understanding each step, it will help you identify where some of the issues might occur and how to optimize for performance if you see any kind of delay or any kind of inefficiency. So let's scroll down. Our build and deployment must have been successful. Finally, we can see here that Docker image has been built and pushed to the image registry, and our web application is successfully deployed. So if we visit our app here by clicking on this button, we can see the Next.js app that we deployed with a domain that is provided by Sevalla. After our app or our application is deployed the first time, we have, again, if we want to deploy more changes, we have two options. One is the automatic deployment, which we have already enabled, by the way, while creating the application. When it is enabled, your application redeploys every time you push something to the connected branch, in this case the main branch. And this whole setup is perfect if you have development and staging environments, or you have teams which follow the continuous deployment practice, or if you have applications with comprehensive testing pipelines. But any kind of application that you have, having an instant environment to test on, to see results on, is always a good idea. That's why automatic deployment makes more sense in most of the use cases. So if we go to our all deployment space, we only have the first deployment which we had triggered manually. So what you can do, let's go back to our code, make a change here. So let me say change 1. I'll commit this code, second commit, and finally we'll push the changes to our main branch. And after the code is pushed, we can go to our dashboard and we can see that the deployment is already started for the commit that we just pushed. So this is called an automatic deployment, which starts every time you push something to the specified branch. The same way, we also have manual deployment. You click on this deploy an app button and select your branch and click on deploy application. Another deployment will get triggered, which is a manual deployment. And that's pretty much all the basics that we need to understand about application deployments in Sevalla. In the next video, we'll explore some of the advanced patterns when it comes to application deployment.